So whenever you're ready, Patrick, go ahead.
Alrighty, sounds good, Jenny. Appreciate it. Yeah, so we're going to take quite the tour of mesoanalysis applied to winter. Obviously, big success of the RMA, right, with summer, but how do we apply a lot of those concepts, a lot of those practices, and different practices for the winter? So we're gonna dive into that, right? So I'm never opposed to a shameless aviation analogy. So let's go there. So you've flown the en route portion by the global ensemble suite. You know, maybe the cams have helped set you up on final here. Now you got to get this thing on the ground, and you're landing at Oshkosh here on the right. So, and I was in the right seat for this, so it's a little intimidating. Luckily, someone else, Ron Williams, is at the controls. But we all know there's that one shift, right, where, man, you're feeling good, like we got this system nailed. And then things start to get a little wobbly. You know, whether it's 3 hours out or 12 hours out, there's always at some point some sinking feeling that this is not going to work out, right? And sometimes we got to let the stew cook a little bit, but we've all been there, right, where you're sitting there like, man, those temps are still pretty warm, or, well, here comes a dry slot, or it should be snowing. Why isn't it snowing, right? You know, I've woken up on plenty of midnight shift, and there was nothing on the ground, and it just leads to a very sad night the rest of the night till I go back to work, as my wife can attest to. So this is where we enter in mesoanalysis, right? It's all about landing the forecast, getting it on the ground. And one of the biggest challenges, I think, with winter storms is that we start telling the story 5 to 7, even sometimes longer days out, right? We've been telling that story for sometimes a week, right? So there's a lot of energy that's been expended, but we still have to get that forecast all the way onto the ground, right? And work through the event and keep that momentum going. So we're going to talk about that. So what are the keys to mesoanalysis for the winter, right? Well, the number one thing is staffing for the position, right? Like if you don't staff it, it is not going to happen, right? So it's kind of intuitive, but it's a big key there. Do your weather ops plans staff a mesoanalyst, I should say. And then we'll throw all the rest of it up there, right? Then it's a combination of everything, right? It's, you know, the understanding of the foundational conceptual models. How do I navigate and mine all the various data sources everywhere? How do I marry deterministic and probabilistic concepts? And how do I be prognostic and not just diagnostic? That's like R.L. Cohen's big thing with mesoanalysis. It's not just being diagnostic, but how do we take that to be prognostic? And then the most important thing is communicating both internally and externally. Like, you know, mesoanalysis for both things, yes, there's the targeted threat messaging out the door, but equally important is the DSS to ourselves, right? If you're the forecaster in charge, like, you know, what's my what do I need for staffing wise 12 hours from now? Well, how are my headline setups, right? So these are, and we're going to touch on a lot of this, but the number one key is actually staffing the position. And if we don't do that, well, then the rest of this presentation is pointless. Above all, right, so this winter, you know, all mesoanalysis, and, you know, it's not just a summer thing, right? You can apply this to any hazard. It enables operational agility. It helps us to be more proactive and less reactive, right? Like, oh, wow, that dry slot is coming at us. We're going to have to do something about that, right? Instead of just like, oh, it's here. Oh, wow, that was really, I didn't expect that, right? And so trying to be just more proactive is a big key here of the whole point of why we're doing this. So again, we will focus on winter, but this applies to, you know, apply this to any hazard, these mesoanalysis principles. It's really, you're approaching the data here, right? And how do I pull that data apart to organize my thoughts into like physical models, right? You know, so if I'm looking at something, you know, I just want to pull that data apart and, okay, that matches up with this conceptual model, or physically this is what this is representing, right? And so then I can use my expertise to provide actionable intelligence to either our partners or the public out the door, or to my coworker who's in charge of the event as the incident commander in office, right? Foundational is kind conceptual models, right? Like, these are, this is the textbook conceptual models of all things winter, from conveyor belt theory to the squall line of winter, which is the snow squall, to frontogenesis and all this stuff, right? So we need to have a solid foundation of what our conceptual models are for whether it be summer, whether it be winter, because they provide really that diagnostic base and the bridge for us then to become prognostic. If we're able to bin the data in these physical models, it really helps us to, like, I know what that is, and now I know what can happen in an hour, 2 hours, 3 hours from now. So, rarely does everything fit nicely into conceptual models perfectly, right? So, how similar or dissimilar things are fitting into those bins, it tells you a lot about where you are on your hazard and probability spectrums. But again, it's first trying to apply those foundational conceptual models to the data and seeing how they're fitting and how they're not fitting. And that tells us a lot about how predictable is this, right? It's full power meteorology. We won't go through all this, but, especially as we look towards say a new ops model, right? Well, there's still a lot of full power meteorology that's needed to get these forecasts on the ground, right? And this is your opportunity to bring that. All right. One thing I really do want to talk about is confidence. This is a very common thing that I've heard from a lot of folks. And I'm not talking about forecast confidence. I'm really talking about forecaster confidence. I hear it from a lot of folks of, I don't know if I got the confidence to do some of this Meso-A stuff. And I'll be honest with you. When I first started the RMA and I was doing some QLCS tour, events in Kentucky, just first starting out, I was like, oh boy, I think I know what I'm doing, but I'm not fully comfortable either, right? So I get it. I've been there, and I still am there too. I'm like, well, I don't know what that is, so I'll call it a blob of something on the radar, right? So we're going to focus on this forecaster confidence because I think this can be a big hurdle to Meso-A, right? Yes, absolutely. You go into, especially with the RMA has kind of opened the doors, right, to mesoanalysis, and now all this data is flying around, all these conceptual models are being applied. Do I know what data is? Do I know what all those conceptual models are? There's some signatures that are pointed out, like if you tilt your head to the right and squint on a Tuesday, you might be able to see what that signature was. I get it. I've been there. There's some risk, right? You're going to get very near-term feedback, right? If you're right or wrong, you're going to know relatively quickly whether you're right or wrong. That's okay. Maybe you're looking into your forecast toolbox and you're like, some of these tools have gotten pretty rusty, and I tossed out the user manual for that tool a long time ago from my brain, and I have no idea what that means anymore. A big thing that a lot of people talk about is, well, how do I bring this all together? How do I fit everything together, right? And the beautiful thing is that this is all okay, right? You don't have to be perfect at this. You have this full understanding of all things mesoanalysis. But the key is to just start, right? We build confidence by doing, and we do it just one thing at a time. I tell this to our own staff, that the most important part of a mesoanalysis is that if you see something, say something. And there's an asterisk to that. I didn't say if you see something, compose the most perfect mesoanalysis post with flawless and deep science, and it just dazzles everyone, right? You don't have to do that, right? The purpose of this isn't to dazzle your colleagues into like, wow, they have a great understanding of, and how would they ever see that? Man, that's amazing. Well, you know what? The purpose is just to recognize that, hey, something might be there, and let's look into that. And if you got to call it a blob of something on the radar, call it a blob of something on the radar, and let's talk about it, right? But the big thing is, if you see something, just say something. And if, hey, winter dual-pol is not my strength, and how do I incorporate it in the mesoanalysis? Next chance you have, give it a try, right? So we'll go over some of those things. All right, I think it's enough already, right, on some of that stuff. So let's bring in the slides with the nice pictures and the colors, and let's really dive into something, well, that is some deeper stuff, maybe some less weighty topics. All right, where to start is a great question, right? The process can be complex, but it doesn't need to necessarily be complicated. And I think the first thing we need to ask or to know is what questions should I be asking so I know what I'm trying to answer. And that depends upon where you are in the event. It also depends upon your winter storm mode, right? We absolutely pound this in during the summer on your storm mode, right? And all the implications that has on how you're going to approach that problem, the threats it has with it, right? But what your winter storm mode is also very important. And it's not necessarily shear across a boundary, but where am I sitting with? Is it a Colorado low, which I would say is the winter supercell, right? Like there's a whole set of questions that I have to answer there that are going to be necessarily maybe a little bit different than maybe that winter mini supercell, which is the Clipper, which is dropping in from a northwest flow. That's going to have probably some different set of questions. Our Arctic front, our winter squall line, right? That's a whole separate thing. And then we have the subtypes if you added mesoscale banding, lake effect up on the where we are up here on Lake Superior, terrain across the west, even a little bit across the North Shore up here. And then oftentimes it's a mess, right? But knowing what your winter storm mode is can help you to understand what questions I need to ask and how I need to dive into this. So if I got that winter supercell, that Colorado low coming at me, you're going to start off with the big conveyor belt theory, right? You're going to be trying to understand, how much warm air am I going to push in, right? Where's that dry slot going to be? Where's my trawl going to set up, right? A Clipper, that mini supercell, that fast propagating system, it's a separate challenge because you got kind of everything happening kind of with the Colorado low, but it's happening in a much shorter amount of time. And maybe you got 2 more Clippers behind you, right? The Arctic front, the winter snow squall or the squall line, it's snow squalls. It's ground blizzards for all my former colleagues in the Northern Plains, right? Oh, the dreaded banding, right? You're going to carry low predictability right to the end, right? Lake effect. You're going to go from, where's this meso low going to set up to where's the fire hose going to come off? Terrain, well, there's darn rocks getting in the way, right? And that has implications. And then sometimes we just have a mess. But knowing, okay, where am I starting here from what my mode is can help me to understand what questions I'm going to have to try to answer. So let's dive into that. So in winter storms, winter mesoanalysis is different because it's long duration. It's not just 3, 4, 5, 6 hours and it's your neighbor's problem. It could be days of mesoanalysis. So let's say we're sitting at Duluth right now. Our low is going across Colorado. And we're hundreds of miles away. Do we have to be doing Meso-A? Well, yeah, right. In this case, that warm front's across Iowa. We know it's going to be marching north. So part of the mesoanalysis effort at this point, when this low is hundreds of miles away, is, okay, let's watch that warm push, right? How far north is that going to get? Because that can really mess with your snow accumulations, as I've unfortunately had happen to me many times. Where are the pressure falls, right? Like, am I actually tracking the low, right? And then, there's the local effects. Well, even if we're 100 miles away, in this case, we're going to have lake effect bands, some terrain enhancement in our neck of the woods. There's going to be, you name it, a local effect, even if you're hundreds of miles away. Okay, let's fast forward. This low is now across entering the mid-Mississippi Valley, and now the questions are getting more and more. Now we're still keeping our eyes and trying to answer those questions on P-typing in the warm air that's working its way up in the warm conveyor belt. Are we going to get elevated convection that's going to make its way into us, right? Again, where are the pressure falls? Where is this low tracking? Again, we're still having to keep our eyes on all those conveyor belts and that dreaded dry slot, right? Which it can absolutely ruin everything, plus the local effects, right? So there's a heck of a lot to do here, even when that low is still, 2 CWAs away. Now we're busy. Things are happening, right? Low's coming into to western Wisconsin, so we got a heck of a lot to answer, right? We got to figure out P-typing in the warm air. How much of a warm air push is there going to be? Are we still going to maybe get elevated convection wrapping around in the conveyor belt? All right, now I'm thinking about this trial in mesoscale banding, and oh man, are we going to wrap around, blizzard and blowing snow? Are the trees going to win? Are they not? Waves of energy looking upstream into the warm conveyor belt, and you can probably pick out, oh, there's a blob of cold clouds, and there's a blob of cold clouds all in the warm conveyor belt. That's all rotating towards me, right? Still keeping our eyes on the conveyor belt, still keeping our eyes on all those local effects, right? And then mesoanalysis still isn't really done when the thing's getting out of here, right? Because a big part of it is also tracking areas of sustained improvement. Do we have that remnant blowing snow? Do we lose the ice and we coat everything in freezing drizzle, which always seems to happen? And then the local effects that just won't go away. So that, multiple days of mesoanalysis. So it's a long duration effort, but it all comes with knowing what questions and challenges am I going to have to answer before I go dive into the deeper specifics. So, all right. So what's the difference, right, between winter and summer Meso-A? So yeah, obviously maybe the tempo is probably not as great in winter Meso-A. You got a little bit more time than in summer, right? But I think there's actually more data to keep track of in winter mesoanalysis. And let's think about that, right? Like webcams are a huge source of information in the winter more so than they are in the summer, right? And some CWAs are blessed with having more webcams than others, but keeping track of the webcams is just as important as any other piece of information in mesoanalysis. So you got those to keep track of. Oh, you also got plow cams to keep track of. MPEG lighten up all over the place. Rotor reports. Again, that's telling you the direct impact, keeping track of that. Oh, power outages. Well, why is there a power outage there? That might tell you something. Mining all the reports on social media, all the pictures of everyone sending in their, picture of ice on their car or snow piling up on their deck rails, right? And then you're scrutinizing like very tiny thermodynamic ranges that have a major impact in your final outcomes, right? So you're keeping track of all that. Plus, you probably have more interaction with ensembled NWP as well. So I think there's, in many respects, while the tempo's not as great, the amount of data you have to get through is probably in some respects more so than in summer, especially when you don't have WAFs. Boy, it wouldn't be nice to have WAFs for winter, but that's another presentation. So, all right. Move forward slide. There we go. All right, so it's also important to have a game plan by data type. So here are kind of the 5 pillars of winter mesoanalysis, right? And what's the game plan of what each thing can tell me, right? There's a whole separate talk on radar, but radar, especially in the winter and everything dual-pol, can easily slide off your plate, right? So you want to try to put that back on the plate, right? It can tell you major insights into your melting and refreeze layers, your prolific ice growth, and loft and aggregation into intense snowfall rates. Really can help point out mesoscale features. Don't forget about velocity and the VAD wind profiles, because that has a lot of it. It's not just for your photographs during the summer. Then we're always battling the radar artifacts. Satellite. All right. Well, it's not just, oh, that's a lot of spin there and that low, but how am I going to pull apart to understand where the conveyor belts are? How am I pulling apart where I can the ice presence or lack thereof? Where are my jets? Where are my impulses? That can all at some point be a little intimidating, but if you just start with, like you can do in the summer, just a big long loop of water vapor or something, and just like stare at it for a while and let it jump out at you, like, oh, there's 2 blobs of really cold clouds in this warm conveyor belt all heading at me. That means something. You folks in Grand Forks, Bismarck, right? Blowing snow extent on some of those RGBs, right? For all of us in the Great Lakes, lake ice coverage and character, right? Are there cracks? Are we still going to let some heat go through? Are we going to float in a bunch of ice and absolutely create this wall of ice so we don't have lakeshore flooding? Where's my upright instability being released? And then trying to fill those holes for radar outages. We talked about OBS, right? from MPing to road reports to power outage maps. There's a ton. Plus, you're keeping an eye on, oh, did I just drop 1 degree and now I'm going to have a completely different P-type? And, upper air. Thankfully, we have ACARS back, right? We've tried it. We have all the fuse data, right, from MSSR, FRANA, MRMS, road temps below freezing. And then we have all the NWP and a lot more interaction with the ensembled NWP than we probably do during the summer. Objective analysis trying to help us fill in the gaps, but we're also trying to identify where the objective analysis is off. Right? All right, so we'll dive in a little bit more into the specifics. One of our, again, your biggest advantage, I think, in winter mesoanalysis is webcams. Whether it's a webcam, whether it's a plow cam, and then everything's probably layered on some type of travel map, right, for road conditions. So this is great. This is gold, right? This is exactly what's going on. And analyzing this data is mesoanalysis, right? Yes, we want to get to the point where, oh man, you see that in Dual-pol and this compares to this conceptual model and that, but if you just a starting point is this, right? This is mesoanalysis too, because this is all observed data. It's no different. It's probably better than a surface observation, right? What does Fgen and dendritic growth look like? In the end, it looks like that, right? So if you're taking a tour through the webcams, you're making your loop through it, and well, that's interesting. I can relate to physically why that would be there, and what have I missed? Or yeah, that's actually in line with my trend. So we're bringing these processes and impacts to life, right? So webcams, plow cams, road reports, that's all mesoanalysis. It's not just the traditional nuts and bolts meteorology. This is part of it. This is a surface observation. This is from, what was this? This was from the Halloween storm, right? This is I-35 between Minneapolis and Duluth. And this tells you exactly, wow, what's happening, right? And we can back that up with what we're seeing in the radar with CC all of a sudden blossoming from a mixed mess to CCs becoming uniform everywhere. So we're literally seeing the process happen right before our eyes in this changeover from rain to snow as a result, in this case, of dynamic cooling. Power outage maps, same thing. Why are there red circles where there are? Something's happening there. Is it radial ice accumulation? Is it we've got a fire hose of coming off the lake? Did we dump a bunch of concrete, this super heavy wet snow, and we dumped a bunch of wind on it? Are we getting a bunch of freezing drizzle? And I remember days in Bismarck where there's like 6 inches of like rime built up onto the power lines, right? So this, again, it's a surface observation, and going through this data set is part of mesoanalysis. I thought about this one. Boy, if someone could code this up, I'd put you in for an award. A low tracking map. Right? Like we have the forecast lows map from WPC, but I know I don't. Are we keeping track of where the low is? Or are we getting caught up in, what's the next run? What's the next run? What's the next run? Well, where is the low not right now actually, right? So if we had a low tracking map, again, I'd put you in for an award. I do my best to give you a national climb, okay? So, because this is important, and it's something that I think we can oftentimes lose track of. Well, where exactly has the low been, and where does that compare to where the NWP says it is? And this reminds me of a system from a couple of years ago where we had this wobbler, right? And, it's wobbling around all sorts of places in the NWP, but where is it actually in reality? That's a big thing, and this is going to start this days in advance. So. One of the big plug for the viewer, the GIS viewer, which is our Jonathan Wolf, who you all probably know and love for all the outstanding things he makes, is one of the developers on the viewer, especially of the observed. And if you click on any of the op sites, and you can get these trend maps or trend charts of all the main pieces of data. So it really helps us to keep that eagle eye on those surface observations when a degree or two makes a difference, or when we can see, in this case here at Duluth, from the Halloween storm, of literally the wet bulb cooling happening before your eyes, right? And are we keeping track of that? All right, we're sitting at 39 over 26, right? But what's the implication of sitting at 39/26 with moisture inbound, right? So again, and it's when a degree or two, as we all know, makes a huge difference. And how well are we in tune with those surface observations? And if we dump a degree or two or raise up a degree or two, we have a whole different scenario than what we maybe thought would be going on. I won't touch. I mean, this could be a whole separate talk, but then you have all this, right? You have all that observed data, and we'll go into more observed data, but you're also still having to marry it to all of this, right? All the various options and flavors of NWP visualization from you name the country and it's NWP, right? You can have a viewer for it and all sorts of ways to slice the data, right? But you're still going to be interacting. Big part of mesoanalysis is also marrying this up to not only those deterministic conceptual models, but also marrying it up to probabilistic data sets, because let's face it, you could be holding on to a heck of a lot of uncertainty really, really, really close to the event, where your snowfall might be 0 to 12 and take your pick, right? So this is a big part of winter mesoanalysis, probably more so than in the summer, unless we have WAFs, which is a whole separate thing. But again, this is winter mesoanalysis too. Like you're still, because the tempo is a little bit slower and the duration's a little bit longer, kind of this intensive NWP analysis, I think we could lump that into mesoanalysis. Why not? It's important to have, I think, really good setups in AWIPS, because not everything is easily found on online. And we have the SBC mesoanalysis for winter, but there's its drop-down menu isn't as big as everything else. So. And we can share these out if you want, but how are we building good winter mesoanalysis? Get too wound up and excited about this stuff. Are we building great winter mesoanalysis procedures in AWIPS, right? So here's one that is bread and butter, at least here, where we try to bring together all the main ingredients from deep layer forcing and Fgen and instability all lined up together with, okay, where's my mid-level, low-level moisture or lack thereof? We need a lake effect panel here. Maybe you need some type of terrain panel, right? And then, everyone is going to have to deal with wind and blowing snow, right? So the big ingredients of deep layer forcing, of moisture, of thermodynamics, of kinematics, do you have a procedure that pulls that all together, right? And we saw this in action, right? So, if we just look at here, this is, this blob is Q-vector convergence in the upper, right here, in the upper left. So we got this big blob of Q-vector convergence, I mean, coupling with a heck of a lot of frontogenesis. Okay, that's a lot of lift. So that's going to probably cool things dynamically and cause that changeover from rain to snow, which we saw in the previous webcams. Another favorite is that we've developed is this layered forcing and moisture, where we look at omega and RH with respect to ice and Fgen, the RH and omega in these temperature layers instead of pressure layers or height layers, because then we can see, okay, where's the best omega? Are we supersaturated with respect to ice? Where is that occurring, right? It's almost like a plan view kind of look at the crosshair technique on a cross section. But that's going to tell us a lot about the crystal habits, right? And then layering up the Fgen, coupling that with it of where's that slope, right? How is that lining up with the saturated air or not? And it also makes pretty clear where that absolutely dreaded dry slot will come in and ruin your day. So this one's been shared out, the snow squall procedure. This is basically what this does is that this breaks apart the snow squall parameter into mostly its components, right? Like everything, like STP, like you name it, of a derived parameter, it's important to know the physical things that are going into it. And what's really important, especially for your winter procedures, is to have them tuned for winter. Like, are your satellite procedures, have you adjusted the color maps from summer to winter so that things stand out more? CAPE, well, guess what? 40 joules per kilogram of CAPE is meaningful, right? In winter, right? So do we have our procedures tuned for that? The big thing is, you can always, take a picture and just like draw things on it, right? You just don't have to take it at face value. So really bring the conceptual models to life with deterministic NWP. That's kind of the whole point of deterministic NWP, is to really, it's our best way to display those conceptual models. This is just a caveat. We dealt with this one over the Halloween storm. The href, I'm just throwing out the caveat there. Like, it's great. It's a major component of mesoanalysis, but its snowfall can be a little misleading. So basically, the point here, as the caveat, is for each ensemble member, it's assumed to be all snow. PF goes to snow if the member indicates that snow comprises at least some of the precipitation. So if you have snow, it's going to trip sending a lot of its QPF, just to snow. So this can really lead to an overestimation during mixed precipitation. And this is something we're battling. Like we're looking at this and analyzing, really, we're going to get to 12 inches, in this thing? This is just a symptom of, the algorithm and having that understanding of how some of these algorithms work. Like href, right? It's great, love it. But if we are in those marginal thermal regimes and we're tripping a little bit of snow, well, it's just going to send everything to snow and lead to a lot of snow. So an NWP caveat. So, and stop me if there's any questions. I'll just keep going and going and going. But all right. One thing that some of you have probably used is the Mesoscale Trends Viewer. What do you know? Developed by Jonathan Wolf here, right? Just continues to build great things. So we have some bundles that we can share out to, the great thing with, that tool is that you can, very quickly view the trends in all the parameters across multiple hours. And then, you're stacking everything up so you can build these vertical structures in Fgen, and how that's relating to our deep layer forcing and instability and dendritic growth zone. And you can build out essentially your own procedure of heavy banded snow on your PC, right? Utilizing the SBC data. Again, the SBC data has its caveats, being a 40-kilometer grid. But very quickly here, we can see, we're stacking up all the Fgen. We see how it's increasing or decreasing in time and how that's aligning or not aligning with instability and dendritic growth zone depth. So let's talk about Fgen for a little bit. Probably one of the, it's like, I don't know, like the cape of summer. It's the cape of winter, essentially. It's that important, right? So this is shamelessly stolen from Tommy Grafenauer, Steve Flegel, and Phil Schumacher from the Northern Plains. Phil's not moved on, but Fgen, mightily important, right? We need to, it can really key us in on where things are going to be organized or not organized, and our snowfall rates, right? So let's talk about that, right? So there's first two bins, right? There's organized and unorganized banding, right? So here's one of my, I was sitting in my living room or somewhere, like, wow, that's pretty impressive banding going on to our southeast. But are the bands transient or are they stationary? So obviously these are fairly organized, right? But they're kind of wobbling around a little bit. They're not locked in. So we kind of have these elongated radar returns. In this case, because they're kind of transient, that Fgen is probably not as strongly influenced by synoptic forcing, or maybe we're not coupling it with really deep layer Q vector convergence. And sometimes it can be just more associated with warm rarefaction, where if things are much more locked in and stationary, we probably are having that Fgen, which is much more influenced by synoptic forcing, and they were probably feeding in maybe a little bit more instability, compared to unorganized bands, right, where it's just weak forcing, right? Whether it's weak forcing in the presence of maybe some upright instability, and we don't have a lot of synoptic support. So these were great, produced by Tommy and Steve and Phil. That's why I stole them, right? Like, how is my baroclinic zone? How is that oriented relative to where the low is tracking, right? In this case, we have a north-south baroclinic zone and a west-east moving wave, right? So So in this case, we know that the heavier snowfall, that Fgen will be more transient, right? It's just going to kind of march along with the low. And that's because the primary mechanism really here is warm air advection, right? So in this case, if we have a north-south oriented baroclinic zone, east-west moving wave, things are just going to keep marching along. So we'll kind of get this transient band, which is largely driven by warm air advection, compared to if that baroclinic zone is parallel to the movement up the upper level wave. And so essentially what's going to happen is that you're going to remain much more, at least appear to remain much more stationary as, the band is essentially training over you, right? And then, from here, we need to assess how much we've coupled to deeper layer forcing and instability. And then we kind of can get a combo, right, where the low can interact with, say the baroclinic zone is at a 45-degree angle. And as the low begins to interact with that baroclinic zone, it kind of begins to wrap it around itself, i.e. maybe you can start to think about, the trowel forming here. And we're able to kind of pivot this baroclinic zone in Fgen over the same spot, leading to longer duration snowfall rates to really be able to pile it up. And then we kind of leave the baroclinic zone behind, and it's weakening, but it's still snowing. So there's a lot of considerations of and this all applies to Meso-A. Okay, how is my baroclinic zone? How is that oriented relative to how my wave is moving? You can think of it as loosely akin to, okay, compared to summer, where's my boundary and how's my deep layer shear crossing that boundary? It's parallel, 45-degree angle, completely perpendicular, things like that. So in scenario one, if our mid-level baroclinic zone is perpendicular to the movement of the wave, they're just going to kind of move together. There's fairly high predictability here because things are moving along. They're not have a less likelihood of remaining stationary. As things remain stationary, that's when the uncertainty goes up, because it's like, how long is it going to stay there, right? If we have this baroclinic zone that's parallel to the movement of the low, well, we know it's going to snow, right? But we start to lose predictability in the exact magnitude of the amounts, like how long is it going to stay there? And, is that going to wobble around a little bit? And the same is true, like if we had that baroclinic zone at 45 degrees, right? And then it's going to be tilted and pivoted around, right? The low. We know it's going to snow, but again, we start to lose predictability a little bit, and just the how high we could go. The ceiling gets a lot higher, right? And so our predictability then gets a little bit lower. And then where's that going to wobble around to, right? This is great graphic produced by Phil. This has probably been in every single piece of Fgen training, for years, right? And then we all have to marry that up to instability, right? The more instability that we have, the narrow and more intense that band's going to be. So in this case, on the left, we can see that we probably have a lot of instability because we're getting multiple bands that are much more intense and narrow compared to if we have maybe a little bit bigger synoptic system with a little bit less instability, whether you're trying to assess that via mid-level lapse rates or EPV star, take your pick, whatever works best for how your brain works. We just don't have as much instability. We know that that band is going to be broader and weaker compared to a much more narrow and intense band. We have a whole lot of instability. We break down into multiple intense bands, which we kind of see here on the example I had left. I don't know, this is just a random musing here, that you can get a big difference in the depiction of your instability based on what field you're looking at. So I kind of like to look at max 2 to 6 kilometer lapse rate compared to 7 to 500, because we can really try to find those smaller, really sharp lapse rates. And you can see the difference in the depiction compared to 7 to 500. It's got 5.5 over the northern Red River Valley there on the North Dakota-Minnesota border. And the max 2 to 6 kilometer lapse rate is like 8.5, right? So it's a whole different depiction and, potential, larger footprint in, well, the instability and its resulting implications. All right. We're going to start to move a little bit more towards now into P-typing, right? Well, here's another bundle for you, right? Again, using Jonathan's Wolf Mesoscale viewer. And a big part of Mesoanalysis is also we all take in data differently, right? And what setup works for you? Maybe having 64 little squares staring at you is just not going to work. Maybe it is, right? So here's a bundle. You can adjust how many hours are displayed, and you can go into Jonathan's Mesoscale trends viewer and play with all that. But okay, again, let's build a bundle here, which gives us vertical structure of our thermal, right? And all the way down to the surface. And what's my, your max and min TWs and all this. It's a great way to just build out the conceptual model of what's happening on a plan view, and then backing that up with diving deeper into the details, because this is a 40-kilometer grid. Yes, it's kind of snapped back to the observations, but it's a 40-kilometer grid. Very shamelessly stolen from Chauncey Schultz, great friend, and Sue at Bismarck. This is stolen from his wonderful tidbits that if you don't have them, I'd email Chauncey and ask for his winter tidbits and his training, because they're awesome. But soundings are important, right? It's no grand thing there, right? But some of our CWAs don't have soundings. Some of our CWAs also don't have any ACAR soundings, right? Like, it'd be nice if we all had that, right? But what we can do, though, is that if we kind of have this starting point of where we're at, we can kind of back out what the sounding looks like from reports. Like, okay, we were really saturated with a warm nose of +4. And my NPing reports, my social media, my METARs were saying a certain thing, and now they've all flipped a whole different depiction. So then I can kind of back out physically what that sounding now looks like. So I can have that conceptual model of where we stand physically based on what some of these ground truth observations are telling me. Radar can do this, satellite can do this. And you don't necessarily need another sounding to tell you what your sounding currently looks like, right? It would sure help, be nice. Maybe we'll get there, in the as we look towards, what is the next generation of all of our equipment, right? But we can back out our sounding structure from ground reports and radar and satellite, so we know where we're starting at, and we know all of a sudden, boy, all the webcams have a glaze of ice on them, and they didn't 2 hours ago. What would my sounding look like now to support that? So thank you, Chelsea. I appreciate these. All right, let's dive into radar, right? It's more than just reflectivity. For a long time, that was all that was on my winter procedures, just good old-fashioned out-of-the-box reflectivity, right? So, but there's a lot that can fall on the floor, right? There's a lot that it can tell us about prolific ice growth aloft, aggregation, P-typing, mesoscale features. We're going to take a very quick tour of this, and let's go. So one of my favorite things is good old KDP, right? KDP is probably the most trickiest one to understand of all the dual-pol moments, made even more tricky during the winter. But one of the big things with KDP that we want to talk about at first is having the right color map, right? We're not looking at KDP 4, 5, 6, 7 plus, right? We're looking at KDP values of like 0.2, 0.3, right? And your summer KDP color map is just going to wash that out, right? So we got to have our color maps that are built to make those stand out. So what we have here is we can see this fire hose of KDP coming off the off Lake Superior into the North Shore. I mean, this is not just a lake effect thing, right? It happened everywhere. Well, why are we getting KDP that is elevated, right? So, well, elevated KDP aloft can really tell you about where we're generating a lot of ice crystals aloft, because these ice crystals, they kind of flutter around horizontally, and I wish I would add that slide actually now. They flutter around horizontally, right? You make a lot of dendrites, they kind of flutter horizontally. Horizontal things cause these, slow, cause a phase shift more in the horizontal than the vertical, and so you can get this kind of boost in KDP. You'd also get a boost of ZDR. So if you look aloft and you see relatively elevated KDP at 0.2, 0.3, 0.4 degrees per kilometer, you're generating a lot of ice crystals. You're probably also going to have positive ZDR. And then that all goes down to the surface. They clump together. They aggregate. KDP and ZDR decrease towards the surface. And you get really intense snowfall rates from these aggregates. We won't go into much detail there. There's a whole Dual-pol clinic on it. CC, right? We can literally see in this image changing before our eyes in a matter of very few scans. We're going from a kind of a muddled mess aloft of a mix of rain and snow, or partially melted, fully melted, not melted hydrometeors aloft. We can literally see before our eyes how we're very quickly changing over aloft to all frozen targets, likely all just snow aloft to, from where we had a mixed phase aloft. Now we've got to get to the surface, right? But we can see right before our eyes how CC is rapidly changing, and we're getting a rapid shift aloft in what our hydrometer types are, which is going to likely lead to a rapid shift in what our surface hydrometers are. The refreeze signature. So this is from Kumjin et al. The big takeaway here is, we have this melting layer. We get that nice ring of lower CC as there's a mixed mess in the melting layer. ZDR is nice and high, and that's that circle because things are a little bit more horizontal than vertical because of the melting, and they're a little bit more horizontal than vertical, so KDP is also higher. But what they also found is that there's the refreeze signature, which once you get down low, you actually get a bump up again in ZDR. And that's something that can clue us into sleet. So, all right, here it is. Here's our nice, beautiful melting layer. Reflectivity is high, right, because of the bright banding. CC is really low because we have a mixed phase of targets, and ZDR is really high because they're a little bit more, they look more like hamburger buns because of the melting, right? But then we have this inner ring of higher ZDR, which is the refreeze signature, right? And we won't dive too deep into the details of why that is. Some of it is preferential freezing of smaller drops. And so those would have a higher terminal velocity, and so they fall off faster. So you're kind of left with everything that's just still a little bit more melty. So as we're refreezing, we're preferentially freezing those smaller droplets first, and they're falling out faster. And so that's leading to a rise in ZDR there because we're kind of left with a little bit more horizontal targets that are still a little bit more melty. And then there's kind of the slushy core thing, which is absolutely mind-bending, and we won't go there. Great example here from Wilmington, and big thanks to Seth Benal for pointing this out to me when I asked this a couple years ago. Hey, I need some sleet, cases. This is, when they, I think, stacked up like 2-3 inches of sleet over Wilmington, Ohio, right? And we can see it stand out. Thank you, Seth. We have all the main moments up there. We can see our melting layer with the high CC, the high ZDR. And then within that, we have this, we see it's not a perfect circle, right? But we see the ZDR kind of increase again, right? And this is a classic sleet sounding, right? We have a strong melting layer aloft, strong refreeze layer at the surface. They're fairly, that's a sleet machine, right? So we'll take a zoom in here, and there it is. So we see that this kind of increase in ZDR within that inner ring of melting. So what's happening there, that's the refreeze, right? We're going back to sleet. We're preferentially freezing some of the small drops. They're falling out first. The things that still are partially haven't frozen all the way, that are still more horizontal because they're a little bit bigger, are left, and that's why we get that spike in ZDR. So you can kind of see this. If you have a higher ZDR within the melting layer ring, it might be refreezing it and generating the sleet. This is like the, it's not a snow angel, it's like a sleet angel here, like in the ZDR. But this is a little bit later in the event as cold air is working its way in, and we can see exactly what's going on. So if we march from the upper left to the lower right, this is all snow. CC is really high. We know the cold air is working in. CDR is fairly low, so that's all snow. And then if we look off, we'll look first over as pebbles, right? So we know our warm air is off to the southeast. ZDR is relatively high, CC is relatively low. So we know it's kind of a mixed mess in the melting layer. And then we go to kind of this inner part near Hillsborough, which ZDR is much more, lower. CC is a lot higher. So this is everything that's fully melted, right? And then we can see where we go back into where we have an inner ring of higher ZDR, which now we're going from those fully melted, everything's fully melted, to now things are refreezing again. And we had that inner ring of ZDR. So we can kind of see the impact of the cold air to the northwest and kind of the tilted structure of the melting layer aloft. So this is very recent. I think it's like the last radar one I have. We'll bring her home here soon enough. So heck of a lot going on here, right? So this is from the winter or the Halloween storm from literally 20 days ago. And we can see over the I-35 corridor between, you can barely see the northern part of the Twin Cities all the way up to Duluth. Our CC is becoming what was a mess. It is now becoming much more uniform as we're dynamically cooling. We're changing over all snow. We're watching that in the radar. We're confirming that with the webcams. That hopefully was a conceptual model we built out by looking at our Mesoanalysis procedures and seeing that we're having this giant blob of vertical lift coming at us that's probably going to cool us from 34, 35 to 33, something like that, to maybe switch us more over to snow. Our beam is going high enough aloft that, man, that KDP is high over St. Cloud, Cambridge, Elk River, into the western part of the Twin Cities, which is just off the image. So there's all that prolific ice growth aloft, and which was absolutely dumping heavy snow on the western parts of the Twin Cities into the I-35 corridor. Mesoscale features, we won't spend a whole lot of time here, but other than they're just kind of cool. Big thing to not let fall on the floor is velocity. It still can tell you a lot, right? So here's this low-level jet screaming down Lake Superior, being compressed by just the shape of the lake as it comes to the head of the lake here at Duluth. And we can see 45 to 60 knots, literally just off the deck, going to be careening into the terrain. Those bad wind profiles, hey, they're not just for photographs during the summer, right? Tells you a heck of a lot of information as well about momentum transfer. Back to Seth and Wilmington. All right, so here's you can see the velocity pattern matching this pattern that we're seeing in the SQT, where we have low level flow from the northeast, because that's our colder conveyor belt working that sub-freezing layer in and that refreeze layer in, and then we see the southwest flow aloft going the other way, building up that warm layer in the warmer advection. Super quick on satellite, right? Won't go, this would be like a whole other course, essentially, but I think it's like March, I don't know, a couple years ago. That's all you can see here, right, in satellite, and there's not much other data on it. It's just, hey, look at the satellite image, right? And what can you see? You can see the differences in air temperature, right? Like the snowpack is yellow over North Dakota. It is green over Minnesota. So that tells us a lot about the thermal regime. We have shallow convection breaking out across southeast Montana into central South Dakota. We have this expanse of low-level clouds that are liquid-topped. We have horizontal convective rolls into the northern parts of the region, and what the implications of that potentially on maybe snow squalls are, would we be able to drill down and maybe see some blowing snow across the Red River Valley? Again, it's sometimes it's just easy to just start with this long loop, right? What can you see here in this long loop? Well, we see convection breaking out southwest of the Twin Cities, and that's releasing a bunch of latent heat. And that's all coming into essentially the low and really strengthening and helping to wrap up our low, strengthen our our trowel. And what's the downstream implications of that? Okay, I see convection breaking out across southwest Minnesota. When it gets 250 or 200 miles to the northeast into the colder air, how is that going to interact with the conveyor belts and the colder air and drive a heavy burst of snow on the North Shore? Kind of these wave trains, and you can see kind of these bursts up and down in the radar as we get one wave train after the other coming across us. I think this is you've almost made it to the end. I've almost made it to the end. This is from just a couple days ago with our system that literally, well, is still impacting us. And all layer precipitable water, right? Big thing that we're looking for is converging moisture streams. Like we can see, not only do we have, in this case, we're just pulling Gulf moisture anyways, but we're adding onto that remnant tropical moisture that's in the Gulf, and we're adding on top of that in the mid to upper levels, a convection to Pacific moisture. So we have these converging moisture streams that's sending a heck of a lot of moisture our way to play with. All right, so it's ingredient-based approach to Meso-A, right? Here's your wonderful recipe cards. I've only got 2 of them, I'm sorry. But it's really the big thing here with Meso-A, ingredients approach. But Grandma's favorite recipe, which is the State Fair Blue Ribbon recipe, is communication, right? Internally, your Meso-A is going to impact the public desk. It's going to impact those TAFs. It's going to impact your IDSS forecaster for messaging. It's going to impact your event coordinator for staffing and operations tempo. And then everything else that goes out the door from AFDs to news chats, weather stories, and DSS packets. So there it is. There's Grandma's gold winning recipe. Mesoanalysis, it's not just for summer anymore. Your ops page, if you want, this is what we use here to try to collect everything together. And yeah, I think that's all I got. So staff for the position, do things well, and I'll take questions, or everyone's just worn out too. So that's all I got.
Awesome. Thanks so much, Patrick. If you do have questions, feel free to raise your hand or put it in the chat and I can read it out. While you're thinking, I'll ask a Sue-related question. So this is obviously a lot of information to keep track of. How do you keep your staff trained on this? Do you expect everyone to be experts in this, or do you have a kind of a core group? Just how do you work through this every winter to keep everyone sharp?
Yeah, sure. It's an outstanding question, right? And what we do is my staff is, they make fun of me all the time, but I produce way too many slide decks. But it's a good thing, though. What we do is that we demonstrate this almost every event. We have this pre-event slide deck where we are demonstrating and marrying up these deterministic techniques and probabilistic techniques, and we build it out for every single one of our bigger events. And then we do an AAR after almost all of our bigger events. And they don't have to be like the whopper of a blizzard. Hey, in this advisory event, let's put together a quick 4, 5, 6 slides on some of the signatures we saw from the MVP. And oh yeah, did you see that in KDP? And did you realize, wow, that was really cool what we saw. So we just demonstrated again and again and again. I have a team that's stepped up. We call it our quick response team. And they really helped me build out these pre and post event case studies. Now, as everyone, not everyone has to be, to the level of, you have to be the ultimate in Meso-A. But what we've seen is that, people are picking up some of these tools. Like, yeah, I can look for that KDP aloft, or yeah, I can pick that out in satellite. And so it's just bit by bit. So the expectation is that not everyone needs to be an RMA facilitator, right? But you just put one tool in the toolbox at a time. We slowly build that up, and we just demonstrate it before and after every event. We build it out again and again and again.
Awesome. Thank you so much. We did have a question from Mike. Mike, the recording will be posted, but Patrick, if you're okay with it, if you wanted to send me your slides, I could post it alongside the recording. Just totally up to you.
Oh, no, sharing is caring. So we can share that out. And Tyler, I see your question too, and I can send you that KDB color curve as well.
Great. Do we have any other questions? Got a comment from Matt in there about the procedure ideas. And then it looks like we also have a question from Carl. So Carl, go ahead.
Hey, yeah, I guess this is more of a comment than question. And Patrick, you might have already covered this a little bit, and I might have missed it among your many, many awesome things that you covered. But I'm gonna throw a plug for two things. The importance of antecedent conditions in the analysis of, like, say, your landscape, kind of fits within the winter meso-analysis role, I would say. What are your, for instance, do you have a snowpack? Is there crust on your snowpack? Do you have ice on your lakes? What are the ground and surface temperatures going to do, and how is that going to have implications on your event? And then second plug would be what really helped me get more confident in winter meso-analysis was merging the NWP type displays with satellite. And as your satellite is evolving, utilizing NWP to help maybe identify the types of forcing mechanisms, maybe those airstreams that are driving your synoptic and mesoscale environments. So I don't know if there's any budding winter meso-analysts out there, but I would definitely throw a plug for looking at satellite in addition to or simultaneously with NWP guidance.
No, Carl, absolutely. Those are fantastic points. And we definitely have procedures here where we, because it helps to, just match that up, and whether you're overlaying it or multiple panels, but your NWP and obviously they don't have to be in separate procedures. They can play together, right? They can play in the same procedures. And it's a great point about antecedent conditions. I get it. Being in Bismarck for all those years, got my start at Grand Forks, and literally part of it wasn't Meso-A back then because we didn't call it that, but I'd put my boots on and I'd go walk around in the snowpack and kick it like it's kind of not crusty, and that was about the extent of what we could do. But and it's so true, because we're being neighbors, right? And like the trees kind of like are our border almost, and so it's like what's going to happen where maybe it's kind of tree covered, kind of not on our border, and that's a big thing trying to understand as well. Great points, Carl.
All right, thanks everyone. I was kind of partway through reading Matt's comment when I highlighted it before, so just wanted to mention that he had recommended highlighting near freezing temperatures and wet bulb temperatures, and that there is a link there in VLab if you want to do that as well.
Awesome.
All right. I don't see any other questions, so really appreciate you giving this talk, Patrick. I think there's a lot of interest. I will be sure to post the recording as soon as it is processed, and then I will link the slides there as well. So thanks again, everyone, for attending, and this will conclude our guest speaker series for today.